Hello guys, we are back with our new video. In this video, we are going to discuss about the definition of covalent bond along with its classification and its nature. So without wasting any time, let's get started. Okay, let's start with the definition of covalent bond. Now, what is a covalent bond? We know for covalent bond, we are having two conditions. It can be formed between non-metals only. Yes. Second thing, it can be formed by sharing of electrons between the non-metals, or you may say between the atoms. Those are forming molecules. So with these two conditions, we are going to get form the covalent bond. Now let's see one example. For example, if I'm forming the bond between hydrogen and chlorine, so very first we will draw Lewis dot structure. So what do we do to draw the Lewis dot structure? Very first we will check the valence electron of hydrogen. As its atomic number is 1, we know hydrogen has only one valence electron. Okay, now let's see about chlorine. Now when we are checking the atomic number of chlorine, its atomic number is 17 and it has 7 valence electrons. Yes, it has how many valence electrons? 7. Let's draw it. 1, 2, 3, 4, 5, 6 and then 1, 7. Now if they are sharing these two electrons, after sharing these two electrons, your hydrogen is going to have 2 electrons in total. While if I am checking it for chlorine, what it's going to have, in this case, after the sharing of these electrons, chlorine is going to have in total 8 electrons. So which complete its octet. Yes. So it means here we have seen hydrogen and chlorine both are non-metals and they are sharing their electrons and forming this bond between hydrogen and chlorine. What this bond is? This bond is a covalent bond. But which covalent bond this is? It's a single covalent bond. Yes, because they have shared only a pair of electron in between of the two non-metals. Now let's start with the polar covalent bond, but before that let's discuss about the mean of polar. What's the mean of polar? Which explain the polarity of covalent bond. When do we see the polarity of covalent bond? When the atoms of the molecule has partial positive or partial negative charges. And how did they get this partial positive or partial negative charges? Due to their relative electronegativity values. Now let's see how it comes when we are checking the same example that we have done at the back. So if you will check in the periodic table, you may see your hydrogen has electronegativity 2.2 while chlorine has electronegativity 3.2. So if you will write these electronegativity values here, then on comparing these two electronegativity values, you may see your chlorine has more electronegativity. Very first. Now second thing, we can check the electronegativity difference among them. So electronegativity of chlorine and electronegativity of hydrogen is in front of you. After subtraction, you may see they are having the difference of 1. So if the electronegativity difference is more than 0.5, then the covalent bond is marked as polar covalent bond. Now let's see how it comes. Now you may see, you have already discussed this thing, that hydrogen and chlorine, they both are having a pair in between these two atoms, that we have already seen. Previously this pair lies in the middle of both the atoms, but due to more electronegativity of chlorine, this pair will get shifted towards chlorine like this. Now when this pair comes towards chlorine, now your chlorine is going to has partial negative charge, and as it appears far away from hydrogen, your hydrogen will get partial positive charge. So this would result the polarity in this bond. So that's why this type of covalent bond is marked as polar covalent bond. Okay, let's do the discussion of non-polar covalent bond. So when a covalent bond behaves as a non-polar, if it forms between the same atoms of either same electronegative values, or you may say with the atoms having very less difference in their electronegativity values. So that we have to take care if we are looking for non-polar covalent bond. So what are the conditions? Atoms are either of same electronegativity values, or they would have very less difference in their electronegativity values. Now let's see. If I am having, for example, if I am having hydrogen molecule with me, which I can write as H bond H. So here if I am checking their electronegativity, I know the electronegativity of hydrogen is 2.2. So let's write down here. So if we are checking their electronegativity difference, we can see it's going to be 0. So if they are having no difference in the electronegativity, then this bond is going to marked as non-polar covalent bond. Yes. Second thing, let's see one more example. If I am having methane molecule with us, now you know about the methane, it is CH4, and here I am having carbon and hydrogen. Let's check the electronegativity of carbon. The electronegative value of carbon is 2.5. Okay, if I am having the electronegative value of carbon is 2.5, while the electronegative value of hydrogen is 2.2, let's check it for one bond, because it's going to be same for rest of the three. So if we have already checked that hydrogen has electronegative value 2.2, while carbon has electronegative value 2.5. Now let's check the electronegative difference. So when we are checking the electronegativity difference here, so the electronegativity of carbon is what we are having, that is 2.5, while the hydrogen is 2.2. So when we are subtracting the hydrogen's electronegativity from the carbon, what do we get? We will get only 0.3. So which is a very less difference. As we know, we had discussed that we can see only on polarity when the difference would be more than of 0.5. So here the difference is only of 0.3. So that's why it's also going to consider as non-polar covalent bond. So hope you got it. We will see non-polar covalent bond either for the same electronegative value atoms or with the very less difference in their electronegative values. Now let's check it about the single covalent bond. So what is a single covalent bond? As we have seen in the one example at the back, if only one pair of electrons is lying between the atoms of the molecule, it is known as single covalent bond. Now let's see, if I am having hydrogen, I know hydrogen has atomic number 1, so it has only one valence electron. Now let's draw its Lewis dot diagram. Similarly, for next hydrogen, again it would also has one valence electron. So if it also has one valence electron, they both are going to share their one electron only. So if I am making a cloud here to check their number of electron, does they completing their doublet? Yes, the first hydrogen completing its doublet by sharing 2 electrons now. Now let's check it for the another hydrogen. Again, it also has 2 electrons after sharing. So it means its doublet is also getting complete. So it results a formation of bond in between of them. That's going to be known as single covalent bond. Similarly, wherever in any of the molecule, let's say if you are having C4H10, in this molecule you may see you are having 4 carbon which have attached with 10 hydrogen. They all are having only one bond lying in between of them. So what it means? It means they all have shared a pair of electron in between of their atoms. Now let's do the discussion of double covalent bond. So what is a double covalent bond? It's pretty simple. Like in single, we have written or we have discussed if one pair of electron gets shared. Now in double, if two pair of electrons get shared between the atoms, that's going to form as double bond. Let's see about oxygen. As we know, oxygen has atomic number 8, while here its bond capacity is 2. It means it can share 2 electrons to complete its octet. Now let's see, I'm having oxygen. So if it has 8 atomic number, it means how many valence electron it has? That is 6. Okay, if it has 6 valence electron, I have drawn the Lewis dot structure of one oxygen. Now the second oxygen is also going to have 6 valence electron. Now when I will draw a cloud here, I can see my first oxygen has 8 electrons after sharing. You may count it 1, 2, 3, 4, 5, 6, 7 and 8. Similarly, if I will draw the cloud for next, again it's going to have 8 valence electrons, 8 total electrons after sharing. You may also count it 1, 2, 3, 4, 5, 6, 7, 8. So what it means? It means they have shared in total 2 pair of electrons. It means if I'm saying 2 pairs, I'm saying in total 4 electrons. Yes. So if they have shared 4 electrons in total, that's going to be known as double covalent bond. Now let's go to next. So let's talk about the triple covalent bond. So what is a triple covalent bond? This is a covalent bond. It gets formed if the molecule, or you can say if the atoms of the molecule share in total 3 pair of electrons. 3 pair of electrons. That's going to get formed triple bond. 3 pairs of electron. So which one will get share 3 pair of electron? Whose bond capacity is going to be 3. Now let's check the bond capacity of the elements. As we know, if I am moving in the second period from lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Now you may see the bond capacity of lithium is 1, while the bond capacity of beryllium is 2. What is the mean of bond capacity? Bond capacity means they can form only one bond, while beryllium can form only two bonds. Similarly, if you will check it for boron, it's going to be 3. For carbon, it is 4, while for nitrogen, it is 3, and for oxygen, it is 2, and for fluorine, it is 1. So why nitrogen has 3, oxygen has 2, fluorine has 1? This I am going to cover in the next video so that you may check. In this video, we are going to consider here directly the nitrogen's bond capacity is 3. So now let's see, if nitrogen has bond capacity 3, it means nitrogen is going to share 3 electrons. Now let's take the another nitrogen in front of this. So if I am taking the another nitrogen in front of this, that's also going to share its 3 electrons. As we already know, nitrogen has atomic number 7. So how many valence electron it has? It has 5 valence electron. So after sharing the 3 electrons, you may see the 3 pair of electron. After sharing the 3 pair of electron, now if you will count the electrons here, how many electrons in total they have? 1, 2, 3, 4, 5, 6, 7, 8. Your first nitrogen has in total 8 electrons. It means its octet get completed after sharing 3 pairs of electron. Now let's check it for the another nitrogen. So if I will check it for this, again it has 1, 2, 3, 4, 5, 6, 7 and 8. So you may see it also has 8 electrons after sharing. Its octet is also get complete. So due to the sharing of 3 pairs, they will form triple covalent bond. Thanks for watching my video. Don't forget to subscribe, like and comment.